Hello, Stockholm. Thanks for coming. I'd like to talk to you today about a subject that some of you probably think is pretty boring, but I'll try to make it not quite so boring. What kind of changes will you as developers have to go through to adapt to a cloud-based world? Now, I want to ask you a question to start with, just to see if I'm right about this whole attitude thing that you have. So, what are you more excited about, the cloud or the latest superhero movie? Who votes for the cloud? Who votes for the latest superhero movie? Okay, it wins about 2-1. That kind of proves my point about the boring nature here. So what I'm going to try to do is explain some of the high points, and I'm going to go from the immediate stuff that you have to worry about down to longer term stuff. So if you do a lot of work in the cloud, some of this early stuff will be familiar to you. So just hang on for 3 or 4 minutes, and I'll try to keep that part entertaining too. But we'll get to something hopefully more interesting a little bit later. I do have a warning though. This is all just my opinion. I don't represent anybody, and we have a saying in America. Do you have something like that there? Like that here? If you're so smart, why ain't you rich? So we say it in the South, and I'm not rich. But I am independent, and I do a lot of different work. I've been doing this development, writing code for money. I'm celebrating my 40th anniversary doing that. Can you imagine that? Longer than some of you, thank you. Longer than some of you have been alive, and I do lead real teams that do real work, and we do a fair amount of stuff in the cloud. So let's go through then some of the things that you need to know. The first thing that people think about with the cloud is that there's replacement of infrastructure. You've got some machine that starts to spew smoke or something, and you realize that you need to replace it, but what you'd really like to do is package that application up and run it on another machine. And you walk over to your server room and realize that you don't have enough room there, so you go and you stick it in the cloud. That's a pretty typical scenario in a generic fashion for what goes on in a lot of IT centers today. This is known as infrastructure as a service. We sometimes call this in English lift and shift is the shorthand for it. And the cloud offers a lot of scalability for those apps. If you take and shift an app to the cloud, and you happen to need a lot more capacity than it expected, you can just turn the dial and get faster machines and more cores and more storage, or multiple machines if the app is constructed for that. So you can get scalability pretty easily. So why do you care about all this? Well, you don't. IT people care about it, but in my experience, developers generally don't. In fact, in my experience, developers generally don't care about much of anything if it doesn't involve writing code. Is that a fair statement? In fact, I will go beyond that. I think that many developers like writing code so much, they are effectively substance abusers. They're addicts. That's sort of my mental image of how they feel about code. Let's get rid of this. Why are you there? So is there anything about, go away. I should have turned off my Outlook. So is there anything about infrastructure as a service that is interesting to developers? Yes, there actually is something. We ran across this a few months ago. You can use cloud-based virtual machines as your development boxes. And there are actually some very good reasons to do that. Who in here is using a cloud-based VM for development now? Anybody? Oh, you will be. I'm surprised. I did expect to see a few. We started this about 3 months ago. Why would you want to do that? Well, we're consultants. We work with multiple clients. So in many cases, the setup to do development for client A is different from the setup for client B. Therefore, it's very convenient and useful to have isolated boxes, even if they're virtual, to do that. And I can actually show you a couple of mine, just to let you see an idea. I've got a couple of virtual machines here. This is a virtual machine. You can see right up there, running Visual Studio. If I start to put up a particular kind of application in Visual Studio, I can bring it right up and create it, and I can code and just go about my business. I have another one that's actually up running a demonstration version of one of our clients' apps. Let's put that virtual machine down and bring the other virtual machine up. It's right here, I think. And because of the rescaling, every time I do it, it has to be shown again. But we actually have an application that's up. Oops, it makes me sign in again because, and I don't remember the password, but I have it right here. Oh yeah. How many of you have far more passwords than you can ever remember now? This is actually a real app. I have, the last time I counted, I have 65 passwords to various things. So this is a typical sort of application. This app, for example, has a dashboard where you can drag things onto the dashboard, and you can. So this is a WPF app, complex desktop app. You can move things around, and when you get the thing the way you want, you can say, yeah, that's fine. That's the dashboard that I want. So I'm actually running that app, that server, or that's back in the United States on an Azure VM. Our distributed team uses that particular VM to demonstrate the app to people and to test certain aspects of it. So that's a couple of VMs for development, and they don't cost that much. You probably get scared off. If you go to kind of set one up, you'll get a screen like this. Now, if you have an MSDN subscription, a Visual Studio subscription, you get some Azure stuff for free, like $50 a month or something. I don't know what it is here. That's what it is in the US. So you can go and set up virtual machines, and you can pick any operating system you want. You're a developer like a kid in a candy store. That's the English phrase. So if you're doing Unix development, fine, set yourself up a Unix box or whatever you like. They will show you projected costs. When you pick the operating system that you want, you get to choose how many cores and how many gigs of RAM and how much storage that it's got. And of course, the cost ramps up if you do that. But typically what we find that for typical development scenarios, we end up paying about $40 or $45 per month for that box if we're using it 6 or 7 hours a day. So you only pay for the hours that you use. So there are estimates of cost as you configure the machine, but those estimates assume that the machine runs 24/7, that it runs all the time. So go down to about 20% of what they tell you, and that's probably about what you have. There's also other situations where it's really, really helpful. We had one situation, you may have run into this, where you have to work on 2 different applications, but for whatever historical reasons, one of them requires a version of a framework, and the other one requires a different version, and the versions can't be installed on the same box. Anybody run into that particular situation a few times? Yeah, I see some nods there. Well, this is pretty convenient then. We just set up 2 different VMs with the 2 different framework versions on them, and we're fine. So that's pretty nice. So why do you care about using these cloud VMs? Well, basically, since you're code addicts, you want to get back to writing code quicker. This is less fooling around with infrastructure stuff to get to writing code. If a new person comes onto your team and you go through the whole setup process to get him a development box, it may take after lunch before everything installs and you get all the license keys and everything. And of course, he's a code addict too, so he starts to get a little shaky about lunchtime. He hasn't written code all day. So instead with VMs, you basically just clone one that you've got, put the licensing keys on it. By 9 o'clock, he's got his fix. He's fine. He's doing lines. That's just like the other addicts do. But this is kind of boring, but not a game changer. It does affect strategy on some desktop apps, because if you think about this, Visual Studio is a pretty complex desktop app, isn't it? Do any of you have desktop apps of your own that are more complex than Visual Studio? No one claiming that, and I'm not surprised. Well, if it works for Visual Studio, there are lots of other desktop applications that it would work for. There are situations where people do something like this today. They use Citrix typically. That they want to have the control of the application. They want to have the power for it in one place and just run it from other places. Well, this is an alternative to things like that, because Citrix is pretty expensive. This also answers the question or solves the problem if someone comes in and says, well, we're running the app internally here, but I've got somebody going to Maui next week or wherever. Where do you guys like to go on vacation? Spain? I got somebody going to Spain next week on vacation, but they'll need to be able to get to the app for whatever reason. Well, okay, fine. We can set them up so that they can remote desktop into their Azure machine that holds it. So, not a game changer, offers some reach and deployment options. It means you might not have to make major changes to that app. So here's the problem though. You start to look at all of those cases, and they look pretty boring, and this causes developers to oversimplify things. So you'll see people in the industry say things like this. Who has heard this statement? There's no such thing as the cloud, it's just someone else's computer. Hands please, yes. This is a popular saying. Do you realize that's kind of a silly saying? I mean, think about the equivalent logic if you were talking about restaurants. There's no such thing as a restaurant. It's just someone else's kitchen. See, the problem with that is there are things that you can do with a restaurant you can't do in your kitchen. I can't serve 25 people in my house with everyone ordering something different. I don't even have place for all of them to sit. So can we all agree that that would be a silly analysis to make? Well, it doesn't differ from this in the slightest. The cloud is the source of all kinds of services, things that are not practical for you to do in many cases in your server room. So don't say this. I mean, it sounds cool, and maybe say it to your family because, it sounds clever, but don't really believe it because it's silly. So let's look at then some of the reasons this is not true and some of the changes that are coming about. I have several I would like to discuss. Some of the ones you will use earliest for most of you, the real changes that you'll look at is the APIs that you can leverage. The things you can do that really it wouldn't be practical for you to develop. You might be able to buy a package, but it might be very expensive. So there are many, many APIs that you might use to get radically advanced functionality in your applications. In our most recent project, for example, I put the top two up there because that's what we're using. We're using advanced mapping capability, and we're taking information from that mapping system, and then we're sending it to a cloud-based function to do route optimization. And this particular application is for a company that makes a package to manage fuel deliveries, propane and fuel oil, kerosene. So they'll have 10 deliveries for the day, and the typical sort of routing optimization. There have been packages to do that for a long time. Now there's cloud-based capabilities to do that. They're very fast, and we don't have to install anything. We just call to the cloud and get the optimization done. It's usually a lot cheaper than buying the packages too, because they're not cheap. Then we've got voice recognition. I'm going to come back to chatbots in a moment. We got Service Bus, which allows us to do remote notifications, remote events globally around the world. That's very, very useful, and we're applying that in a couple of our projects. You can even, there's a function, there's an Azure function that will do SMS texting. So if you need, for whatever reason, for your application to send text to users, that's just easy as pie. You can do that through Azure with no problems. There's data analytics. There's just everything you can imagine. Basically, if there's a package you could buy today or last year, there's probably a cloud version that's either already there or you'll be able to get it pretty soon. Now, the one exception to this that, and I see people talk about this, when you go to Microsoft conferences, you're going to get a lot of sessions on bots, on chatbots. I'm cynical about chatbots for a couple of reasons. The first is that the last 4 real-world chatbots that I've run into, that I've gotten on the phone, have been useless. And I mean completely useless. My son, I'm going to show you a Twitter account later where I put some of my most frustrated stuff. My son was at a screaming match at some chat bot that wouldn't give him access to a human. How many of you have had similar experiences with chat bots? Yeah, they suck, okay? And the problem is that people think it's going to be easy to develop one because they go to these demos. And it looks easy in the demo. They just push a few buttons and look, I can talk to it and ask it a question and it will respond. Well, it's kind of easy to get one up at that level. That's not the hard part. The hard part with chatbots is building the entire graph of everything it needs to know to respond with some semblance of intelligence. That's really, really hard. And almost nobody sinks the effort into doing it. So what they do is they just put out something that kind of sucks. And then they let us get frustrated with it, and then they analyze the results that we send them. And they go, oh yeah, people are asking this question. We really should have thought of that, shouldn't we? And that's how they build their bots. Don't do that to your customers, okay? That's really cruel. So I'm not very, very fond of bots, but most of the other things there are extremely good things to look at. So if you look at using these APIs, then what you've got is that your current situation is something like this. You've got devices that run your applications. You've got databases, maybe some logic running above those, and then there's a whole bunch of layers of plumbing in between. This is a generic version of an architecture that most of you probably have. You got some business logic in there somewhere. I've never seen anybody that really has a particularly rational architecture for that. It gets stuck somewhere and usually toward the bottom layers. Well, you can take that existing architecture you have today and you can graft in functionality from the cloud by putting in these APIs for voice and maps and transportation routing and chatbots and stuff like that. All those cloud APIs can be plugged right in. So there's a screenshot, for example, of the WPF application that we wrote that does the routing of the propane trucks. And it sends stuff off to Azure to get the routing, and it uses Bing Maps, which is cloud-based, for all of the mapping. So this is nice. These APIs add a lot of great new capabilities, but they're effectively just bolted on, attached to what you have now. That's kind of good in some respects, because you can just plug it in and use it. You don't have to throw out the stuff you've got. I mean, you've got years of development, many hundreds of thousands or millions of euros in these, or kroner in these. I guess you have to multiply it by 10 approximately for that, or whatever the exchange rate is. You got a lot of money in these systems, and you do not wish to start all over. You'd like to add new functionality, so you just bolt it on. But it is not the end point in using the cloud, not by any means. To understand that, let me tell you about a demonstration I saw at Build and a couple of the implications that come out of it. Did anyone see the Build Day 1 keynote? A few of you saw it. You remember the button demo? One of the Azure IoT guys came up, and he had a little device like this. And actually, I made this work at home, but I don't have access to all the networking to get this thing connected to do it here. So I'll just tell you a little about it. It's kind of silly anyway. Basically, the idea is that with IoT, you can program so that this device is talking through a wireless network straight to the cloud, and the cloud then deploys anything it needs to the device to make everything work right. And then the cloud takes care of the logic. So this is serverless. This doesn't have to talk to any kind of local server to get through to the internet or the cloud. It does it directly. Now, there's the video of that keynote going to the point where this demo starts is at that link there if you'd like to see it. I'll show you very quickly. It's, let's see if I can find yeah. This is, you'll see stuff like this where he's building the application that causes this button to work, and he's got a counter down there. His ambition was to finish it in 5 minutes. You can watch the counter count down as he talks. And so he does in fact make it in 5 minutes. So you can watch him build everything with Visual Studio to make this work in 5 minutes. So what does it do at the end of the day? You press a button and you get a pointless tweet on Twitter. Well, I understand, you want to do something simple if you're going to show a demonstration of stuff like this. But I have to admit, I was in the audience there watching this keynote. And I don't know, I have a funny thing about Twitter. It's kind of pointless to begin with as far as I'm concerned. And I looked at it in 2008 and everyone said, Billy, you should get on Twitter. I read stuff for about an hour and then I established my first Twitter account and I named it This Is Pointless. That account is still up today. It's 10 years now that I've been putting up completely pointless tweets. But I've got nothing on somebody who can press a button and put out a pointless tweet every second. Because all it is, hey, I pressed a button and it gives the date and time. Pretty pointless. But there are some bigger points. So at first glance, it looks pretty useless. You can go out and look at my Twitter account if you want to. It's pretty cynical. So if you don't have a dark sense of humor, you probably don't want to go there. And besides that, I could have hooked a button to my system 10 years ago and knocked out pointless tweets. I'm surprised I didn't think of it at the time. It would have, pre-populated my Twitter account with many pointless tweets, but I didn't. So what was this demo ad build? Well, the presenter really wasn't talking about the tweets. That was just to show that it worked. His point was that you could get IoT devices up and running very quickly with everything deployed from the cloud. Now, why is that important? Suppose you have an application that requires 10,000 devices that are sensors and are going to be sending some kind of data to the cloud. If you have that, you better have a clean way of getting them deployed, or this project really isn't going anywhere. So I understood why he looked at it that way. This was an example of how you could get those devices up and running. But I think he missed a larger point for developers, because after I thought about it for a while, it played into something that I've thought about before, which is when we do eventually change our architecture and move so that most things that we're doing are in the cloud, except for the devices themselves, then we're going to go to a world where we've got the devices and the cloud and a dramatically simplified architecture in between. We're going to lose a lot of layers of plumbing because they're going to become standardized. Well, that's good from the perspective that it really simplifies things. And we get to sort of concentrate our logic there, and we still get to use all those wonderful cloud APIs. Notice that some APIs still are used from the device because that's the logical place to put them. And we need, for latency issues and various other things, we put them there. But the basic idea then is that we eliminate a lot of plumbing. So the question then for you as a developer is that what you do today? Do you write a lot of plumbing logic? Because most of us do. Now the question is that where you consider yourself to be valuable? Because if it is, you ought to reevaluate that. You ought to think a little bit about what your expertise is going to need to be at some point in the future. This isn't immediate. You have plenty of time. There aren't that many companies that are going to a model like this one, except for startups. Very common for startups to do this, because this is the cheap way for them to get going without having a lot of infrastructure. They don't need a server room somewhere. So if you do plumbing, be aware of what that means for you going forward. But this is not where we're going to end up. This is not at all where we're going to end. This is just the beginning of the changes in cloud-based apps. So to go into that subject, I need to ask you a question, and I need an honest answer from you. How many of you just sometimes feel like you're overwhelmed by the complexity of this industry and all the things you have to know? Come on, let's get those hands up there. That's just about everybody. See, I was afraid I was going to have to do a diagnostic and make everybody put up their hands and then heal the ones who couldn't. I'm from Tennessee. I can do that. So you're overwhelmed by it, and that is widespread through the industry. Now, I presume that the people who come to these conferences are kind of the upper echelon of the teams that they're on. Because I know there are a lot of developers out there who they just go home. They don't go to conferences. They don't do anything. They go watch Netflix at night. You think you're overwhelmed? Those guys are lost. Okay? I mean, completely lost. And of course, there's a related problem to that. Your managers are lost too. They're overwhelmed. Look, they don't know that much about what you do to start with. As far as they're concerned, you could be back there stirring a cauldron and saying magic spells. They don't really know. What they know is that it takes a long time to develop software. And they don't really get that. They don't understand it. I've had them talk to me about this. I talk to a lot of managers, a lot of decision makers, a lot of higher executives. I was talking to one day, and he posed this question to me. He said, look, I go to these conferences, usually Microsoft conferences, and they do these demos, and it only takes 10 minutes. They build this amazing thing in 10 minutes. And then I go back to my developers, and it takes them 6 months. What's the problem here? So I grabbed a piece of paper and a pencil, and I drew him this graph. This is the problem that we're up against, and it has been growing over time. You see, if you're going to be presenting in a keynote and you're going to do a demonstration, it better be simple and packaged, because you only have about 10 minutes attention span for the audience. So you better do what you're going to do in 10 minutes. But things get more complicated every year. So every year, the demos are hiding more complexity that they're not telling you about, and that's where the managers get lost. Not to mention the fact that a lot of the development that's being done today is being done on the web, browser-based, HTML5 and JavaScript. It is not, as some would have you to believe, all of the development out there. There is a surprising amount of desktop development still being done. But there is a lot of web development, and let me tell you, the managers really don't like it. Because I had one, for example, come to me and say, my team told me we should do this web stuff, and they needed to do it in Angular because that was the latest cool thing. So they spent over a year doing the app, and then they came to me and said, well, Angular 2 is out. I said, oh, good. Probably some new things. They said, no, it means we have to start all over and write it all again. Look, that does not look good to them when they have to go to the next level up and justify the money. I mean, as far as they're concerned, this whole, this whole mix of JavaScript libraries, just deciding which ones to use is hard, and they change all the time. So this is just something that the managers really don't like, because it has some pretty serious problems. I mean, you wouldn't be laughing at this if I didn't have a point about there being problems, but I've got more evidence. I have a buddy in Atlanta, Georgia, named David Neal. He's an MVP back in the States. He designed this T-shirt and sells it on Amazon. It's quite popular. He sells a lot of them. Or you can buy this coffee cup. This is not from him. It's somebody else. So, and occasionally someone will come out and admit this. At Build 2015, a Microsoft executive came out and said, JavaScript just has problems when you get above a certain level of complexity because of the language itself. So that's kind of where we are with web apps today, and that complexity is really overwhelming. And I think we're kind of reaching perhaps a breaking point there, because I see various other problems. This has been a common theme of discussion among a couple of groups that I'm involved in, is that pages written 2 or 3 years ago don't work anymore. And nobody knows why. But pages written 10 years ago are fine, because they were written on older, simpler technologies. They don't do as much. They're not as nice, but something that isn't as nice but works will beat something that is broken and nobody knows why any day of the week. So I call that page rot. I don't know what else to call it. We used to talk about link rot, links that just weren't there anymore. Now we got page rot. And then one of the big problems that I see a lot of discussion around is that new developers don't really have an entry point anymore, because the amount you have to know to do anything in the web is so overwhelming. And if we can't get new people into the ecosystem, that any ecosystem that doesn't have new people coming in is going to die because there are people going out at the top end, including a good friend of mine, age 50, who died of a massive heart attack 2 weeks ago. This is a stressful business. So, and of course, browser incompatibility, and as I said, the decision makers don't like this. So, do you think the answer then in a cloud-based world is to take what we have now and just put some more layers of complexity on top of it? You ready for another round of complexity? Learn AI APIs and voice APIs and bot APIs and 3D APIs for HoloLens and distributed events. And we don't have telepathic APIs yet, but they're working on that. There's a band that reads your mind and talks to the computer. So you might not see these problems as clearly as your management because, as I said, I talk to them, and they just feel like they feel very unsafe. They feel like they're making bets without any understanding of the risk that's involved. And that's because of the complexity that we've just put up with. And, of course, for a lot of developers, well, you know, if they're writing code, they're fine. They don't care beyond that. And we are working to patch some of this. There are things like TypeScript that will fix some of the more egregious things about JavaScript. But the cloud is a platform change. And it is not common to take something that is extremely complex and messy, and that some of which was written back when other developers were there and they don't understand. When a company changes a platform, it's common to use that as the launch point to re-establish the business application. Not every company does that. There are some companies that just take whatever they've got and package it, and they put another layer on top. And so it's just even more complex until it reaches the breaking point and maybe bankrupts them. But for many companies, when they look at the cloud, they're going to look at that as a platform change. And when a platform change comes along that people need something new, the market will eventually supply it. I've been through a transition like this before. In the late 80s, we had COBOL software. It was starting to get pretty stressed. And then we got Windows. And C++ and going against the Windows API was a very difficult business. And that was tough. It was so hard that Windows wasn't really taking off until Microsoft bought the product of a man named Alan Cooper and turned it into Visual Basic. Visual Basic was released on this day, I think, if my memory holds, in 1991. And I was in line and got a copy at the booth at the show in Atlanta. Now, it was kind of a toy at first, but by 1999, end of the decade, it was the most popular programming tool on the planet. There were all these people who said, "Oh, COBOL, man, COBOL will always rule. COBOL it's just there's too much written in it. That's what everybody knows." How many of you write in COBOL? 1, 2. Okay. I don't mean to make fun of you. There's nothing wrong with COBOL, but it did not maintain the status that the people said it would. So based on that, plus some other forces I see driving change, the changing role of data, for example, the emergence of AI, and cloud-based engines. Let's dive a little bit into some of those. People don't think much about this, I think, but one of the effects of the cloud and the associated technologies is that data has a different role in today's applications than it did 10 or 20 years ago. Most business applications up to now or up to the recent past have focused on someone entering data. Therefore, those applications had a lot of screens for data entry. We call those CRUD in America: create, read, update, delete. Do you use that term here? So CRUD screens. A large portion of every application was CRUD screens. But now we've got data that comes from all over the place. Not only do we still have all of our traditional databases, we've also got a lot of sensors and measurements and activity counts and things. So all this data flows in, and now it becomes more important for our applications to let users use the data effectively. What good is the data if the users can't find useful information from it? So data visualization and data analysis become much more important in this world. Those, by the way, are all visualizations from some recent projects that we've done, that we concentrate on this a lot. That happens. User experience design is one of our specialties, so we do a lot of data visualization. So up to now, we've had all those screens, and you know, the most common design was probably the wall of data grids design. How many of you have that as your primary design philosophy for your applications? Hands, please. Don't be ashamed. It's okay. Who's got walls of data grids? You're lying to me, okay? I know better. I go into companies all over the world. Why are you lying to me? You're ashamed, aren't you? So that's what we do now. And then typically we use searches to find a master record and then go to the detail records. That's just the pattern. But going forward, since we're going to have all this data coming in, we're going to need to find ways to make it easy for people to consume it. And that means, among other things, designing what it's going to look like for the user. You see, a data grid is very handy for throwing the data on the screen, but it's not very handy for figuring out how the user needs to look at it. You have to design that. You have to understand what the user is using the data for. So in the propane application that we worked on, we started, when you do a user experience design, integrate that as part of your development, you do sketches. You do simple sketches. You do more complex sketches. You do prototypes. It doesn't take a lot of time to do this. They're spun pretty fast. Our typical UX design for an entire application takes about 3 weeks to do the biggest parts. And then, of course, you get the final output there. And you can see the progression of the visualization for this particular application. It turned out that understanding how much fuel someone had is very important, because that's the purpose of this app, to make sure people have their fuel. In the northern US, it gets cold. And these people are based in Minnesota. A lot of your distant relatives live there. There's a comedian in the US who says, yes, those people came from Sweden and crossed the ocean and crossed forests and rivers and mountains to get to a place that was just as cold as the place they left. That's what Minnesota is. So they really worry about their fuel. So visualizing when people have fuel is extremely important. Here's a comparison to help you understand. Would you rather look at data like this, some events that happen to a client, in the data grid like this, if you're a user, or if you're just kind of trying to find out what happened, because you can't change these things you see. So you're consuming the data. Would you rather look at it with the view in the data grid, or the view on a timeline, so that you can see clusters of possibly related pieces of information? I did this for them. I actually developed this piece. If you click on a particular one that's partially hidden, it will come to the foreground, and there's other nice features. You can change the span of the timeline and things like that. So if there's too crunched up, you can expand it some. That kind of data visualization makes an application faster and better for people to use. It adds more value to it. Another area where we're going to see some significant changes using AI in business apps, we're going to see more apps doing things like image analysis and recognition of objects and faces. Language translation is another big one that gets better with AI-driven engines every year. Trying to data mine people's or companies' customer databases to figure out who's unsatisfied or who's not making them money. Calculation of risk, et cetera. All of those things are potential applications for using artificial intelligence, about which I have to say a little bit more in a minute, in order to make the application more valuable. There are some issues, though, because commercial AI particularly is in pretty early stages. There was some of you may have heard of this. There was a a case where someone wrote an artificial intelligence engine to detect nudity, which has obvious applications for places like Facebook and Instagram. But what they found was they were getting lots and lots of false positives from sand dunes. It took a while for them to figure that out. Building your own AI, well, you can do it. You got enough data. There's a lot of problems you could solve. And the cloud facilitates this by doing machine learning. That builds AI models. You see, building the AI models is expensive. It's very computationally intensive. But consuming the model is easy. And that's what you're doing when you use these packaged services. So basically in the AI space, the world divides into those who merely consume AI and understand the APIs to do that, and those who actually try to create the models and make AI work. And creating that model is very hard. It requires many skills. You have to learn Python or R, typically, are the two most important languages that you probably don't know. This is another area, by the way, where you'll see people in Microsoft demos do a demo. Look, I'm creating my model. And now don't believe any of that, okay? It's much, much harder than they lead you to believe. It will take you months or weeks just to learn how to do it. If you spend full time on it, it'll take you many months, maybe a year, if you just are trying to do it on your spare time. A little bit less if you've got some real math in your background. Statistics and linear algebra being two of the main things you'll need. I used to teach linear algebra. Does that surprise anybody? I was the guy they didn't want to get to. And there are a lot of different techniques, it turns out. It's a discipline. You learn from experience that this technique will work for this kind of AI problem and this other technique for another one. That takes time for you to acquire those skills, and there are lots of libraries you might need. There's a nice Reddit thread about this, including some links for training if you want to take this plunge, if you'd like to take a whack at it. But I'm not going to fool you like some of the speakers that talk about AI do and tell you it's easy, because it's not. It's actually very hard. And it's also important to understand that the AI needs balance between the cloud and the edge, because creating the models is computationally intensive, but running the models isn't. So in many cases, we want to put the models out on native devices. You could imagine a model running on the HoloLens, for example, to do recognition of objects. That would make a lot of sense. We would want it to be low latency. We wouldn't want to stream that video all the way back to the cloud, analyze, and bring it back. We'd want to be able to do that locally. And those devices are pretty powerful, and they can do that. So that is something to keep in mind with AI. It's not just about the cloud. The cloud is an essential part, but part of what AI does is fuel the need, in some cases, for those native coded devices, for creating the application on the native devices, because that's where the AI will run effectively. Now, besides AI, there's all kinds of other engines that you could put in the cloud. They become more practical in the cloud. We've got a lot of these engines now in the form of packages. But you think about things like tax calculation. I don't know how complicated it is here. In the United States, it's much worse than you think. It's not just 50 states. Every county and every city can pass their own tax laws. And even within a city, a special school district might have an extra tax. So you're talking about enormously complicated calculation of taxes. So if you're selling things in the United States and you need to calculate that tax, there is no way you're ever going to develop that yourself, or you'd be crazy. Packages are used today, engines will be used going forward. Things like medical diagnosis. We don't have this one yet, but I think we will. I think as we build up enough data, we'll be able to mine it and then make a medical diagnosis engine that has the rules to feed in symptoms and figure out what should be done next for a patient. Drug interactions are fairly straightforward. It's just a matrix, but there's so many of them that a cloud-based engine is helpful. And you see some of the other possibilities. And let's drill on a particular example that I happen to have some affinity for because I've used it a couple times, and that is workflow. How many of you have some kind of workflow package or system in your app now? Only okay, yeah, maybe 10% of you. it has been my experience that most applications do have some workflow in them. It's just that it's kind of kludged together and nobody really calls it that. There's some code somewhere that says, well, when this thing is done, do this to it and send it over there. That's workflow. But formal workflow is often helpful in bringing order to that chaos, because if you do enough of that, run some code here and do it there and run some code over there, you end up with a system where it's very, very hard to change the rules of the workflow. So workflow engines help that. This was an application that we worked on in 2004 that did workflow for a company that sold drugs to prisons. It turns out prisons don't go down to the drugstore. They contract, they send in orders, they get them back. These people filled 50,000 prescriptions per day, plus some number of renewals. So they needed to pass around the information about the drugs. The pharmacists needed to approve them. They needed to be mixed up or packaged or pick off the shelf or whatever that particular drug needed. And so we brought in a workflow system that replaced a very simple system that they had before. It cut their unit labor costs by 50%. They needed only half the number of people they needed before. That's what good workflow can do to you. Well, I know this system because I wrote it. The queuing and the rules and everything that goes with it. And I'm here to tell you there is absolutely nothing stopping the same architecture from being done in the cloud, where there's a repository of rules that route the things around, and there's a definition for the different queues that are the work areas. This is all very, very practical. In fact, it is so practical and useful, I'm convinced someone's going to make a lot of money. The English phrase, a ton of money. I'm not really sure how much a ton is, but someone's going to make €1 billion, $1 billion, whatever, in this space, and there's nothing to block it. All the technologies are there. We can make it distributed with message bus or signal R in the cloud, and we can use the cloud as the repository of all the information. Where is everything right now, and where does it go next? All of that can be done in the cloud and exposed to the user as a simple API. So if I were 10 years younger, I'd found a company to do this. But I'm too tired now. 40 years is kind of long enough. So if any of you decide to do it, you could call me and cut me in on the action. I'll help. So how do we manage all this complexity? Well, as we talked about the fact that Windows development was complicated, so Visual Basic came along to fix that. And I think we're going to see something like that now, because the complexity now is even more overwhelming and crushing than it was in 1990. It doesn't mean that the code-centric development we're all used to goes away. It doesn't mean that at all. But it does mean that there is a lot of room in the market for something better. And so my concept is that we put all these pieces together into a completely new concept for developing cloud apps. When you have that much change, usually what comes to fill the gap looks radically different from what came before. Visual Basic didn't look anything like anything that had ever been done up until that time. So what's the equivalent now? I can imagine some things it's going to need to have. First of all, it's going to need to have some emphasis on managing and assembling pieces, because we're going to end up with a lot of these APIs that we have a little package of code that we need to leverage that API in our application, and we need to be able to have that package understood and exposed and managed and plugged in where it's needed. So that's one thing this will need. We need automatically generated UI, some kind of overall markup that says, yeah, we're going to have a vertical stack of these things and a couple of buttons, and now if it's HTML, let's generate the HTML for that. If it's a mobile app, let's generate the Xamarin or something for that. We need tools that are going to be approachable by non-professional developers. We've shut them out, and that's not healthy. It's not healthy for the economy. It's not healthy for us as an industry. And we're seeing some early primitive versions of a tool like that right now. The two main ones that we're seeing call these embryonic forms of what I'm talking about. They have some aspects of what I mean. Google Flutter and Microsoft's Power Apps are the two that we see now. Google Flutter is to do native stuff for iOS and Android, and it does have that ability to target and to each one. You really only write the app once, and then it makes the changes needed. It has this metadata form of creating the UI. The UI is not created in either iOS technologies or Android technologies. It's created in a technology that they then put into those two channels. Everything's very based on pieces fitting together. I talked about the need for pieces. Flutter does this. It's a compositional-based engine, which doesn't surprise me at all because I know one of the architects of it. He was an architect of some other compositional technologies that I've learned. It is for mobile only, though. That's a little bit of a limitation. And it really is targeted at people like you, people who understand code and are very, very comfortable writing it. It's not targeted at power users or people who really are not that comfortable with code. Microsoft Power Apps, on the other hand, is more business-focused. It's heavily associated with the Dynamics, Microsoft Dynamics. They actually wrote a lot of dynamic screens using Power Apps. It's very easy for non-developers. You don't really write code. You use like Excel formulas to calculate things, for example. But you can't write public-facing web apps, and it doesn't go to any devices. It's just for internal stuff running in a browser. That's all it will do. So limitations there, but I've looked at both of these, and both of them have some of the pieces that I've imagined. This cloud-based development environment that does generate UI automatically. And all of the cloud capabilities like voice recognition and things like that should just work transparently. And it has to be, I believe, compositional. We are going to have to shift our thinking as developers from imperative writing of code to compositional putting pieces together. And we do that to a certain extent now. HTML in general, and HTML5 is pieces within pieces. There's a certain amount of composition there. But the most advanced composition language on the planet right now is XAML. XAML is made to put pieces inside other pieces. You can't really work with it if you don't think that way. You can't work effectively. So we're going to see that become, I think, the foundational philosophy because we do have so many pieces to manage. We have to think about how they fit together much more so than writing code that stitches them together. Writing code that stitches them together is going to be too complicated, I think. There should be at least part of it to be used by somebody that doesn't really know how to code. That should be the entry point to draw people in and help them create some of the very simple apps that our businesses need today. People are really suffering for something to create those apps. But you would do coding, you just try to keep most of it isolated into small pieces that then were brought together. I'm going to show you a diagram, and it's too complex to really go through the details, but I'll point out some of the larger pieces. This is kind of my vision, is that this kind of an application should be able to look at data or let you set up what data looks like and take from that to an engine that lets you build a UI for that data and then knows how to spit that UI out into various forms for various targets, which I've listed the main ones up there. But that needs to also, that the UI has to be stitched together with other things, including these cloud engines I talked about. So part of the environment would be to create the wrappers around the APIs for cloud functionality. And then we would want to be able to very easily put those cloud APIs in. So I'm envisioning a compositional designer. I've actually got some sketches where I'm kind of working my way through it. Tough thing to do, very tough. But somebody will crack this problem. I'm convinced. I don't know really how much what the end product is going to look like, that vision in my head, but I do see that we're going to get that radical change because we're just under so much pressure that we can't avoid it. So you should be ready to leverage that when it happens. In particular, I don't mean to be insulting about this, okay? I really don't. But there is a subset of developers who hold people who won't learn all the stuff you know in contempt. that you're supposed to learn it all if you want to be developers. You're not supposed to learn a tool like this. A lot of them go back to the days of Microsoft Access, where some end user would just hack out some horrible system, and then they would have to come along and fix it. That's where they grew their distaste for this. What they didn't realize is that Microsoft Access was furnishing all the demand for software, that people would just hack things out, and 99 out of 100 of them would go away. 1 out of 100 became a massive success, and that fueled the demand for real professional developers to put that into a big scalable form. So please, when this comes about, suppress your distaste. These things are going to be, at least in the beginning, targeted at pretty simple apps. Well, you probably don't want to build those apps anyway. So be generous and let the people who do embrace these things use them to do things that you really just don't have the time to do. All right, let's do a little recap then. So we started talking a little bit about using VMs for development. I was surprised that that's so rare. I think it will become more common, especially for people who are consultants. The efficiency and effectiveness of that is really, really major. It saves a lot of your time. There are lots of new capabilities that we can plug into existing apps with all of these APIs that are on the cloud, services that are being sold. It does mean, though, as we move more to full cloud architectures, that there will be less plumbing, less deployment code. So we want to reorient our thinking and our own abilities around that. There will be a lot more data, but a lot less data entry as we move forward into the cloud world. So we need to do things like visualize that data and help people analyze it. A lot of these engines give us dramatically new functionality, so whole new applications will need to be written. And some of them will need to do AI modeling in the cloud, but push the AI out to the edge. And finally, that crushing complexity, plus the ability to layer on all this other stuff that's going to make it even more complex, I think will probably force the development and adoption of some new development environments. That may be 5 to 10 years in the future, but I do think we will see that at some point.